In this video, we are going to talk about unified modeling language diagrams. So, first off, a little bit about unified modeling language, or UML. It's a general purpose modeling language and it's used a lot in software engineering. So, this is part of the design phase of a project that you're working on. So, you could sketch out the ideas for the project that you're going to have in this UML language. There used to be quite a few different competing modeling languages like this, but it kind of seems, from my perspective, that this is the one that most people use these days, and it's fairly easy to use. What we will do is just take a look at a specific kind of diagram called a class diagram from UML. And the class diagram just shows the classes and objects that make up your project and the relationships also between those classes and objects. There's lots of other UML diagrams that we will not discuss in this class, but you can go to this website here, and that shows a lot more information about UML. Okay, and you can see there's all kinds of information there about it. A lot more extensive than what we will discuss. Okay, so we are going to start off with a class diagram, and well, actually, for right now, that's the only kind of diagram that we are going to talk about. So a class diagram, it describes a program's classes, its fields and methods, and the relationship between the classes and objects that make up a program or project. Okay, so you can get an idea of what classes that you have to write and how they're related to each other, how they're used by each other, and that sort of thing in a class diagram. So a class diagram, the classes and objects are represented as rectangles. So you'll have a rectangle that looks like this, and it's divided into 3 compartments. And in the upper compartment, it basically tells the name of the class. In this middle compartment, it's going to talk about the fields that are in the class. And in the lower compartment of the rectangle, it's going to talk about the methods that are in the class. All right, so in the top compartment, as I said, that's where the class name goes. It goes in the top compartment. We've talked early on in the course about interfaces and abstract classes. So if the class is an interface, or if it's an interface, not a class, right, then what you want to do is write interface in these double angle brackets on top of the name if it's an interface. Okay. And then for abstract classes, you want to write the name in italics. Okay, so those are the rules for the class name that we'll be concerned with. And so that would go here in this upper part. Here you can see that this is not an abstract class or interface, right, because it doesn't have those markings in the class portion of the rectangle. In the middle part of the class diagram contains information about the fields in a class. Here you can see in this diagram we have in the middle compartment, it says minus ID number :int. Okay, so that tells us a few things about the field. It says that the field is has a name ID number. All right, and the type is int. Okay. In addition, the markings out in front of the field tell you about the access level of the fields and methods. So for public, it would be marked with a plus. In the diagram here, you can see there's some pluses here, so these would be public. Private would be marked with a minus sign or hyphen, however you want to say that. So here you can see ID number and balance owed are marked private. Protected gets this hashtag, I guess is the best way to say that these days, or the pound sign if you're old, or number sign before that. Like me, I should say, that's how I grew up referring to that. So, and that's for protected, and then package level access would be marked with a tilde in front here, in front of the method name or field name. Okay. You can see that the syntax is a little bit different from Java, right? In Java, the type would go out in front of the identifier, right? Is here on the fields. And you might wonder, why is that the case? Well, this UML can be used with a multiple different instances of object-oriented languages. So it might be used in C++ or C# or some other object-oriented language like that. All right, so the general format for fields is the access modifier, one of those 4 symbols that we talked about, then the name of the field, then a colon, rather, and then followed by the type. So the type comes after in this UML format. One other issue with fields, if you have a static field, then you should underline the field, right, so that you know that it's static. So this gives a pretty good snapshot of what the fields that need to go into that class will look like. You can just basically look at it in a picture. All right, we already mentioned that the methods go in the bottom part of the partition, and in this particular example, this customer class, we have a customer method and a toString method. Okay. And inside the parentheses, the methods have parentheses, right? Just like methods do in Java. And the parameters go inside the methods. Here we can see we have a method called customer, so we know that that is a constructor, right? And so therefore, you can see it has 2 parameters, ID number of type int and balance owed of type double here. So the parameters in the parameter list follow the same conventions as for the fields, where you put the name first and then a colon and then followed by the type. This toString method has no parameters. You can see that it's just an open and closed parenthesis together. You can also tell the type of the return type, right? Because the return type, as demonstrated here with the toString method, you can see after the parentheses there's a colon and then followed by a type. So that indicates the colon after the parentheses indicates that the return type of toString is a string. Okay, so that's how you can get information about the return type. All right, and for the customer, you can see there's no colon out after the parentheses, so there's no return type there. So that avoid method would also look like that as well, where there's no return type. Again, the general format for the methods is the access modifier, followed by the name or identifier, and then open and close parentheses with the parameters inside. The parameters follow the same name colon type format as fields do. After the close parentheses, then another colon and then the return type if there is one. Okay, so you would just omit the return type on constructors and void methods. Just like with fields, you should underline static methods. All right, and so what you can do is basically, given a diagram, class, and one of these class diagrams, like this one right here, You can basically, it's a template. You can write the code in whatever language that you're using, and in our case Java, right? That fits this class or is detailed by this class diagram. So for instance, for this customer class in code, it would look like this. You have a public class customer, and it had two fields, right? ID number and balance owed. And you can see they were both private. ID number was of type int, and balance owed was of type double. And then here is the method customer, right? The constructor as indicated in the class diagram. And then here is the toString method as well. So what happens is when you're designing a project like this, you have these classes laid out in these diagrams, and then you can, whoever the lead designer probably puts these documents together, and then you can farm these diagrams off or assign responsibilities to team members, and they can code their part of it, their class, according to just by looking at the class diagram, okay, or at least get an idea of what it should be doing or what they have to do. All right. So some information that's missing from class diagrams. Class diagrams don't provide any detail about how the classes interact with each other. You'll be able to look at some of the relationships, which we'll talk about later, and get some idea about how they interact, but it doesn't really tell you the specifics about that situation. And then class diagrams don't contain any implementation details. There's no details in there about, like for instance, if you look back at this implementation that we have of the customer class, it doesn't tell us exactly what this string is supposed to be. It just tells us, hey, you've got to return a string out of this method. So the details aren't in here. That's going to depend on the situation and the people who are writing the code to come up with that. So it's basically just an overview of the classes that make up the project and their relationships with one another. All right, so no implementation details in that. Okay, so that's an overview of the class diagram, and at least for the actual classes themselves. In a later video, we'll talk about the relationships. But what I want to do next in the next video is to draw this class diagram using Visio, and so we will do that in the next video.